All right, so hopefully all this is a review. So let's see how much of this is a review. What's a relation? So a relation can be, I'll give you this one, guys, because maybe we're kind of like a little rusty. Any set of ordered pairs can be a relation. Really, any expression can be a relation. For now, let's just make it simple and put any set of ordered pairs. Some relations are functions, and some relations are not. So what's a function? I don't know. Well, I mean, I do know, but I don't know what your previous teachers told you. They might have told you like it passes a vertical line test, and that's a function. Maybe they told you x's don't repeat. All those are valid. I'm going to put passes vertical line test. The whole idea of a function, guys, is that when you input a certain value or a certain specific input, you get an output, a unique output. And we want to be able to make a prediction based off of like what we put in. You know what I mean? So that's what the whole idea of a function is. Can we make a prediction, a valid prediction? If we put a 2, we get a 5. If we put a 3, we get a 10. If we put a 4, we get a 20. Is there a pattern? What's that pattern? Can I make a prediction of what happens if I put an 8? So that's the whole idea of what a function is. So going with that, notice that I have ordered pairs here in letter A. It says, are the following relations functions? Notice a 2 has a 4, 3, 5, 4, 8, negative 1, 7, and notice a 2 has a 10. Is that a function? What do you guys think? No, x is repeat. So that's the whole idea of like, when is it a function, when is it not? If I put a 2, I better be getting a 4. So if I put a 2 again, I better not get anything different than that 4. I got a 10, so it can't be a function. You can't use this model to make a prediction or anything. Does that make sense, guys? All right, so these are called elements, and this is usually called a set, like set X, and then set Y. And then inside this set, those are called elements, whenever you see them written this way. And there's a whole math course dedicated to all this, number theory and set and subset and all that good stuff. But right now we're just doing basic stuff. So is this letter B a function? What do you guys think? Yeah, it's a function. None of the x's repeat. None of these have 2 little sticks coming out of them, I guess, if you want to call it that. And it's kind of, the arrows are going all over the place, but that's fine. Each one of these has one arrowhead. Yeah, it's a function. Yeah, sometimes they say, is this 1-to-1? Is this onto? And we're actually going to get to that in a little bit. You can also say the x is like the domain, the y is the range. So you always go from domain to range. Look at letter C. I have a table. Is it a function? Nah, no. X is repeat right there. What about letter D? Is letter D a function? Yeah, passes vertical line test. And then it says, what does it mean to be 1-to-1? And I know these notes are probably not very good. I probably need to update them because all of a sudden I just throw that word in there. What does 1-to-1 function mean? Have you ever heard of that, guys? No? 1-to-1. So maybe you've heard your teacher say passes vertical line test and horizontal line test. So when I draw a vertical line and when I draw a horizontal line, I better intersect it only once because it's 1-to-1. It's in the name. Every x has a unique y, every y has a unique x. Actually, I should say every unique x has a unique y, every unique y has a unique x. The numbers can't repeat. Does that make sense? I don't know if my English is proper there with the uniqueness, but yeah, your values can't repeat. The x's can't repeat and the y's can't repeat. So if you draw a vertical line and a horizontal line and it intersects it more than once, it repeats. Does that make sense? Perfect. So what is 1-to-1? You can write passes vertical and horizontal line test. And I know some of you are like, what is it? What do you mean passes? That means that it only crosses once. For it to pass, it can only cross once. Only crosses once. For it to pass. If it doesn't pass, if it crosses more than once, or if it intersects it more than once, it's not 1-to-1. Does that make sense, guys? Okay. Now here we go. Let's read this example. We're going to hit you guys 3 times with this, and then I'll tell you how to tackle them. Determine if the relation from set A to set B, you can also call set A like X's and set B like Y's, is a function. If it is, determine whether it is one-to-one and whether it is onto. Okay, the word onto means every element of Y is used. And I don't know why it's writing like that. I think I need to reset it. Every element of Y is used. That's all it means. So I think I would do the onto first, and I'm going to look to see if every element has an arrowhead to it. Does every element on set B have an arrowhead to it? It is onto, for sure. Is it one-to-one? Well, I don't know. Let's see. There's not 2 arrowheads. Yeah, it looks like it's one-to-one. And is it a function? Yep. It looks like there's 1 coming out of every element of A. So it is a function that is both one-to-one and onto. And don't worry, guys. If you didn't understand that, we're going to do it 2 more times. Cool? So example 2B, it's the same question. It's the same question. It says, determine the relation from set A to set B is a function. Determine if it is a function. If it is, determine whether it is one-to-one and whether it is onto. So first thing I do is I look to see if every element of B is used. It is. So it is onto. Then I'm going to check every element of A that it has 1 little stick coming out of it. It is. So it is a function. Now, is it one-to-one? Do the X's or do the Y's repeat? I see the Y's repeating. What Y repeats again? The 4. So it is not one-to-one, but it is a function and it is onto. So what letter is that? A function, but not one-to-one, or onto? Nope. A one-to-one function, but not onto? Nope. An onto function, but not one-to-one. There it is, letter D. How come you guys didn't tell me letter D? An onto function, but not one-to-one, because of the number 4 there. All right. Example 2C, I'm not going to read it because it's the same thing again, guys. It's asking the same question. So the first thing I would do is look at set B. Is every element of set B used? Nope. Number 1 is not used. So this is not onto. It is a function, and it looks like it is one-to-one, but not onto. Does that make sense? So let's look for that. Letter C, a one-to-one function, but not onto. Good job. How do we feel? Easy, right? All right. Example 3. Determine whether the following graph represents a function. Oh, that's an easy. Just draw a vertical line. Bam. Does that vertical line cross more than once? So is it a function? If it crosses more than once, it's not a function, guys. Because that means X is repeat, right? I have this value that has the same X value as, I don't know, it looks like something, comma 5, and that same number, comma 5, comma negative 5. But it's the same X value. How do we feel? Okay. All right. So if you want to read that, you can. F of X is for a function, guys. I've seen some students confuse this for F times X, and I don't know where the confusion happened. It just means that you have an expression in terms of the variable X. You don't have to have an expression in terms of the variable X. You can have an expression in terms of happy faces. It doesn't matter. So, Chavez, what are you talking about? So, okay, first let's read this. F of X is read as F of X. F, G, H, all sorts of letters are used to name functions. They usually start with the letter F, probably because of the word function. Yeah, I agree. I type these letters out. I type these notes out, by the way. So, and usually when there's multiple equations in the problem, just identify future functions by going down the alphabet. So they probably use the letter F because of the word function. And then if you have more than one expression or function, they probably just go down the alphabet, guys. F of X, G of X, H of X, whatever. I of X is probably not used because I stands for current and it also stands for imaginary. So they probably try to avoid the letters I, J, and K because they mean something. You'll learn about those 3 letters later on. All right. F of 3 equals 5. This is an ordered pair. That just means the x value is 3 and the y value is 5. Yay? Okay. And then I have an expression here. It says f of x equals 2x squared minus 3x. And it says evaluate the following below. I don't have to have it in terms of x. I could have had it in terms of anything. Which maybe next time, you know what? I'm going to update these notes. Update. Next time I'm gonna put on purpose one of the letters. I'm going to say, give me f of happy face. And I hope, I don't know, do you guys like happy faces? If I say f of happy face, I hope that you can tell me, oh, okay, well, here's my expression. Wherever there's an x, I'm just going to put a happy face. 2 parentheses, happy face, squared. That's a happy face, I swear. Minus 3 parentheses, happy face. And there it is. There's my function in terms of happy faces. Oh, we got some happy face haters. Okay. F of triangle. 2 triangle squared minus 3 times triangle. Yay or nay? Yeah. So this one says f of 4. So just using our definition, we're just going to go 2, 4 squared minus 3 times 4. And I guess technically I don't tell you to solve it. So you could leave it like that, but don't. And you don't need a calculator for this. Let's see. 2, 4 squared is 16. And then 3 times 4 is 12. And then if I double the 16, that's 32. And then the way I do it in little increments. So I split up the 12 into 10 and 2. So I go 32 minus 10 is 22. And 22 minus 2 is 20. That's how you do it mentally. There's other hacks, but that's how you do it mentally. I'm not the fastest. So some of you may be able to be faster than me. Was that okay, guys? All right, perfect. So let's go to letter B. This one says f of x plus f of 2. So the number one mistake you guys make is you put an equal sign here and you just tell me what f of 2 is. So don't do that. So go to the side somewhere, and first I'm gonna underline this in blue first. I'm gonna first do f of 2 somewhere. So I'm gonna write f of 2 equals, and I'm gonna figure out what f of 2 is first. F of 2 is 2 times 2 squared minus 3 times 2. Let's see what that is. 2 squared is 4, so I have 2 times 4 minus 3 times 2, which is 6. If I double the 4, that is 8. 8 minus 6 is 2. I am now ready. I'm going to start a new line. All that is f of 2, by the way, so maybe I put f of 2 right here if you want to. Here's my new line. I'm going to change my colors, and I'm going to write f of x plus f of 2, bless you, is equal to, and I write what f of x is. F of x is this expression up there. 2x squared minus 3x. And then I put plus. That plus is this one. That plus is that one. And I write what f of 2 is. F of 2 is 2. And if it's factorable, you could factor it, but I'm going to leave it like that. Does that make sense, guys? Okay. Letter C, and I'll zoom in because I know some of you guys maybe have a hard time seeing. So f of 2x, this I could just put an equal sign there. Wherever I have an x, I'm going to write 2x instead. So I'm going to write 2, parenthesis, 2x close it squared minus 3, parenthesis, 2x close it. Are we good so far, guys? And now we just use our law of exponents. I'm going to put an equal sign. That's that equal sign. 2, so I'm going to write the 2 first. That 2 is this 2. Open parenthesis. I'm going to square that. 2 times 2 is 4. X times x is x squared. Close it. Minus, and then I'm just distributing that, right? 6x. And I'll slow down. I sometimes go too fast, so you gotta let me know, guys. Equals. I'm gonna double the 4x squared. So 2 times 4x squared, that's gonna be 8x squared minus 6x. And if you wanted to, you could factor something out, but I'm gonna leave it right there. But there it is. How are we feeling? Okay. Letter D. So I already started grading some of these because first period and fifth period turned them in on Canvas. Not all of them. The due date that I put was for today for them. So because we were behind because we were reading that out loud. But some of them I already started grading. And it's okay, guys. We can make mistakes on these activities and homeworks. I grade very generous. But there's an error, and I'm going to show you the most common error. So I'm going to write it right here. F of h plus 2. Wherever I have the variable x, I'm going to write h plus 2. 2 parenthesis h plus 2 close it squared minus 3 parenthesis h plus 2 close it. I don't know if you were here during the SAT practice, but I specifically mentioned this. That I'm underlining, h plus 2 squared, a lot of students wrote h squared plus 4. It is not h squared plus 4. I'm going to put this on the side. Let me see, do I have room? If I erase this little arrowhead, I think I have room. So this right here that I'm circling, that means h plus 2. Let me do that again. H plus 2 times h plus 2. Does that make sense to you guys? All right. So let's see if we can do this really quick. I'm going to first write it. That's the equal sign. Is that equal sign? 2 times, let's see, h times h squared. H times 2 is 2h, but you're going to have 2 of those. So I'm going to write 4h. Does that make sense to you guys? And then 2 times 2 is 4. Close it. Don't worry, I'm going to explain it, what I just did. What I did is this. H plus 2 times h plus 2, I'm going to write it here in blue. H times h squared. And then I get h times 2, and that's 2h, so I brought 2h. But then I remember I told you that they have 2 of them. That's because the next time I go to the next one, 2 times h, that's another 2h, see? I got 2 of them. And then 2 times 2, 4. So, h squared plus 4h plus 4, which is what I have right here. Does that make sense, guys? Okay. I post all this online, so if you just want to like focus and follow along, you can just follow along. I'm gonna upload the video to the internet in a little bit to Canvas, so you don't have to write anything down if you don't want to. All right, let's distribute this 3. Don't leave this alone because I have an equal sign there, so I have to have the same expression. Minus 3h minus 6. Make sure you distribute that negative. Is everyone okay so far? I'm going to go ahead and distribute the 2. 2 times h squared, 2h squared. 2 times 4h plus 8h. I'm just doubling everything. 2 times 4 plus 8 minus 3h minus 6. I'll slow down. I'll slow down and zoom in because I can see some of you guys squinting. Did that help when I zoom in like that? Okay. All right. Now I'm just going to combine like terms, guys. I have an 8h. I have a 3h, or a negative 3h. So that means I got to take the difference. The difference between 8 and 3 is 5. The 8 is bigger, so it stays positive. Bless you. Oh, that doesn't okay. Sorry. Plus 5h. I have an 8. I have a 6. The difference between 8 and 6 is 2. The 8 is bigger, so it's going to be positive. Plus 2. I hope I didn't make a mistake. Do you guys see any mistakes? And there it is. We're done. How do we feel? Okay. Here we go, guys. Let's go to letter E. F of negative x. I'm going to put an equal sign here. And let's see. We're still with the same function. 2x squared. So I'm going to write 2, open parenthesis, negative x, close it, squared, minus 3, open parenthesis, negative x. Equals, that equals 2, and I don't have to put a parenthesis there. Negative x times negative x is a positive x what? Perfect. Negative 3 times negative x, that's going to be, not everyone at the same time. Yeah, negative times the negative is a positive, positive 3x. Be courageous, guys. It's okay to make mistakes. No one's going to judge you here, for real. For real. And there it is, that's it. Let's go to letter F. The way I would do letter F, the easiest way in my opinion, put giant parentheses around that f of x like that. See? So here's my negative, giant parenthesis, and I'm just going to type my expression, what f of x is. the expression for f of x, what was it? 2x squared minus 3x. And then I'm just going to distribute this, and that's it. That's all I'm going to do. Just distribute, distribute, distribute. So here we go. That equal sign is that equal sign. Negative f of x is nothing more than negative 2x squared minus 3x. Oh, negative times a negative is a positive. I was testing you guys. It just happened. I make mistakes all the time, guys. All right. Here we go. Ooh, now we got a fun one here. Don't worry, guys. We're almost done. F of x plus h. So here we go. This equals 2 parenthesis x plus h close it squared minus, I think it was a minus, yeah, minus 3 parenthesis x plus h. Is anyone confused with that? And I'll zoom in. We're still good? Okay. Equal sign. That equals is that equals. Here we go. 2 parenthesis x times x squared plus x times h is xh, but how many of those am I going to have? So I'm going to write 2xh plus h times h squared, close parentheses, minus, distribute, 3x, don't forget to distribute that negative, minus 3h. Is everyone so far okay? All right. Now I'm going to distribute the 2, guys. You don't have to do the sound effects. Here we go. 2x squared plus 2 times 2 is 4xh plus 2h squared minus 3x minus 3h. I think we're winning, guys. I think we're winning. Like, what do you mean? Oh, you're talking like when I expand the x plus h squared, if I were to do FOIL, you're talking like x plus h, and you're like x times x squared, x times h, that's xh, and then you're like h times x, that's hx, plus h squared. It doesn't matter. Xh and hx are the same because it's a product. A times b is the same as b times a. So these are considered like terms. So you just add them. So 2xh. 2 like, oh yeah, 2 here, 2xh. Xh plus xh, 2xh. Oh, okay. So usually the rule of thumb is that you want to have the highest degrees on front, like ax squared plus bx plus c. So if you have something, a high power, you put them in the front. So like in your activity, you're going to have like an x set squared and an h set squared. But it doesn't matter, miss. You can put them in whatever order you want. Did I answer your question, Lettuce? Okay. Are you sure? Okay. For the record, Internet, I am not bullying any student. I have a kid whose actual name is Lettuce. So yeah. Okay. Because I don't know if someone's going to watch my video and he's bullying. Like, no, I'm not. You don't feel bullied, right, Lettuce? Okay. I'll probably delete that. All right, here we go. 3 times f of x. That's a simple one, guys. You're just going to go 3, and then you're going to just type giant parenthesis and type what f of x is. And my short-term memory is really bad sometimes. 2x squared minus 3x. Not that I don't know, but sometimes my short-term memory is bad. Not today, because I got some sleep. We're just going to multiply that by 3. So it looks like it's 6x squared minus 9x. And it looks like you're done with that. How do we feel? Okay, very cool, guys. All right. You want to read that really quick? Should we read it together? All right, let's read it together. Or does someone want to read it for us? Okay, I'll read it. All right, peeps, let's try something else. There was this question called the difference of quotients, and it looks like this. This equation is used extensively in calculus and or physics. Actually, it's used everywhere, but today we just want to use it and simplify the difference of quotients. All right. I don't want you to be a robot, so real quick, that difference of quotients, it's literally just finding an instantaneous rate of change. And you're actually finding instantaneous rate of change. They're all over the place. Right now I'm moving my hand. It's at any given moment, it's moving at an instantaneous rate of change. This pen, I don't want to drop that one because that's a $100 pen because it's a digitizer. This pen here, it's moving at every single moment. It's moving at an instantaneous rate of change. And there's a moment where the instantaneous rate of change of that pen, when it was going up, there's a moment where the velocity was 0. Can you tell me where the velocity is 0? I'm going to make sure to catch it. Can you tell me where the velocity is 0 on this thing? Yeah, at the peak, when it reaches its highest moment. But guess what? The acceleration on the pen is always 9.8 meters per second, because it's gravity. So the acceleration is that negative value all the time. I'll let physics take care of it, and when you get to calculus. But yeah, so in case you're wondering, Chav, I'm never going to see the difference of quotient in my life. If you're going to be a medical doctor, if you're going into the science, if you're going into the engineering, this is all you're going to be dealing with. Well, this is not all, but part of what you're going to be dealing with. So you're going to be seeing the instantaneous rate of change all the time. Cool or not cool? All right, so look how awesome this is going to be. So it says example 3, given f of x equals 2x squared minus 3x, find the difference quotients f of x plus h minus f of x over h. Look how awesome this is going to be, guys. First and foremost, we still have the same function. Go ahead and write this first. So I'm going to write f x plus h minus f of x all over h. And don't panic. Are we okay so far? We have f of x, here's f of x, and it's the same function that we were doing earlier, guys, so here it is, it's the same function, remember. Do we already have, somewhere in here, f of x plus h already embedded? Look very carefully, actually, I'm trying to put it there where you guys can kind of see it. Do you see it? Copy that expression. Look, it's right here, you did it on letter G. It's right there. Copy that expression verbatim. So here we go. I'm going to put it there so I can still see it. 2x squared plus 4xh plus 2h squared minus 3x minus 3h. Okay. Minus, that minus sign is this minus sign. And then in parentheses, write your expression for f of x. Don't worry, guys. It looks scary, I know. But it's going to be easy. Trust me. Are we still okay? All right. Take your mad algebra skills and go ahead and distribute that negative. Rewrite all this again, but we'll distribute that negative to your parentheses here. So 2x squared plus 4xh plus, this is what you're going to be doing in a little bit, guys. It's going to be so much fun. Minus 3h minus 2x squared plus 3x. Remember, I put a plus because negative times a negative is a positive. Perfect. All over h. Don't get scared, guys. Are we feeling okay? All right. Now comes the fun part. We're going to zero out whatever cancels out in the numerator. So I see a positive 2x squared. Do you see a negative 2x squared? Zero it out. I see a negative 3x. Do you see a positive 3x? Zero it out. Look what you have left, guys. Look at your terms that you have left. 4xh plus 2h squared minus 3h all over h. Notice that these three terms in the numerator all have something you can factor. What can you factor? An h. Here's my h factored out. 4x plus 2h minus 3, close it, all over h. And now that I have h times something over h, now what can I cancel? Yeah, the h's, because this is h times something divided by h. So now those cancel out. And here is your answer. 4x plus 2h minus 3. Was that cool or what? So when you were in 6th grade and you were to see this, would you cry or would you be like, I'm going to do this? No, you wouldn't cry. You're strong. You would turn up on this. Okay, I'll stop because I'm getting too rowdy here. All right. Sorry, guys. Didn't mean to distract you. Don't worry. We're almost done. We got one last one. So here we go. This one is a different function. Remind me to delete. Okay, yeah. Okay, anyways. You guys remind me. And I'm going to do this again. Cool. So here we go. Let's see. What do I need? Okay, I can't do it yet. So I'm going to do it in blue. I'm going to do this part right here that I'm circling in blue. F of x plus h. I don't have that part yet. So wherever I have an x, I'm going to put x plus h. 1 over parenthesis x plus h, close it, plus 7. I don't really need those parentheses there. So we're just going to drop it like it's hot coffee. I know that doesn't make sense. In my mind it did, but now that I'm thinking about it, it doesn't make sense. All right, so let me tell you about the hot coffee reference, even though it's not really related to this, but let me tell you. So you know the line, have you ever, okay, first let me make sure that I'm not, that you guys even know about this, because maybe I'm too old. Have you ever heard of a rapper named Snoop Dogg? Yes. Okay, well, I don't know, guys. Maybe you, okay. So he has a line that he made a long time ago called Drop It Like It's Hot. You guys have heard of that line? Okay, so in my mind, I'm thinking when Snoop Dogg made that line, he was drinking a cup of coffee, but someone gave him a coffee that was too hot. Like, oh, I'm dropping it because it's hot. And then someone was like, hey, bro, hey, Snoop, that's a good line. Drop it like it's hot. You dropped it because it was so hot. Drop it like it's hot. Drop it. Yeah, that's going to work. And then they just created it. Okay, I know. That's a story I made in my mind. It probably never happened. But I like to, my brain just wanders off. Like sometimes when I'm going to sleep, I think I'm an NBA basketball player for the Spurs, and Coach Popovich is putting me in to shoot the three-pointer. I know, I'm lame, but I'll stop. All right, so there it is. There's my f of x plus h. Oh, I don't know where I was going with this because I dropped the parentheses like it's hot. Like, okay, that was dumb, I know. Now I'm going to go back to red. I'm going to do the whole shebang here that I just circled. So I'm going to write f of x plus h minus f of x all over h equals, and here we go. I'm going to write f of x plus h, 1 over x plus h plus 7 minus, what's f of x? 1 over x plus 7. All this is over h. Are we still okay? And I'll zoom in, I know. All right, I cannot add the numerator, 1 over x plus h plus 7 minus 1 over x plus 7, the numerator, if that makes sense, until I get a common denominator in my numerator. I know, play on words, because there's so much fraction within a fraction. So what I'm trying to say is, here in the top, in the numerator, I'm going to multiply this right term by x plus h plus 7 over x plus h plus 7. If you have colored pencils, here's where it comes in, or a colored pen. And this one I'm going to multiply by x plus 7 over x plus 7. Yeah, if you want beautiful notes, have like 2 different colors, or maybe, you know, light, make one light shade lighter or whatever. All right. Now remember, guys, don't be a robot. This in green is just 1. Anytime you multiply any expression by 1, you don't change the value, because anything times 1 is itself. Does that make sense? Okay, so we're not robots here. So here we go. Here's what we're going to get. Do I have space yet? So 1 times anything is the same thing. So I'm going to have x plus 7 over, and I'm not going to bother distributing, so I'm just going to put those in parentheses. X plus 7 times x plus h plus 7 minus, and now don't worry, right now I'll zoom in, minus, let's see, x plus h plus 7 over x plus 7, x plus h plus 7, that's an h. All this is still over h. So here we go. That's what I got. Add the same common denominators in the numerator, if that makes sense. So I can go ahead and group them like this. I will put a parenthesis here, guys, so you don't mess up with your distributing the negative. So here's what I have. I'm going to zoom out, guys, for a little bit so I can write everything. And I'm going to have this. X plus 7 minus X minus H minus 7. I'm distributing the negative. All over X plus 7, X plus H plus 7. And then all that is still over H. In a little bit, I'm going to bring that H right there. In a little bit. Chavez, why? Side note. A divided by B divided by C. Remember, don't write this down, just listen. In a little bit, I'll give you time. Just listen right now, guys. Remember the keep, change, flip that they keep telling you about? Okay, so that C is like C over 1. So keep A over B. Change the division to multiply, and then flip 1 over C. And notice that the C, so now I have A over BC. So notice what happened. All that happened was, if I have this right here, you just move that C right next to that B. Do you guys see that? So this this is like your quote-unquote A. This is like your quote-unquote B. And that H is like your quote-unquote C. Okay, now you can write down. I'll zoom out so you guys can see. All right, let's cancel out some stuff. Let's zero out some stuff. Oh, I guess not yet. Let's put them together. X plus 7 minus X minus H minus 7 over, here's the H, and then X plus 7 parenthesis X plus H plus 7, close. All right, here we go, finally. The X's zero out. The 7's zero out. Now, once you've zeroed everything out, now I can cancel one of the H's. And here's what you have. You have negative 1 at the top, X plus 7, X plus H plus 7. What do you guys think? Was we good? Yeah. All right. Cool, guys. Let me stop this recording.